Good morning, good afternoon, and good evening for all the attendees of ITB International Geothermal Workshop 2021. It's been an honor for me. I'm Erwandi Yanto as the representative of my team from PT Pertamina Geothermal Energy. On this occasion, I'd like to present to you about our innovations. The title is Optimizing Scale Value of the Geothermal Brine Deposits into the Oil Absorbent Product at Lumut Balai Geothermal Field. So, the outline of my presentation today is begin with the background and issues, the solution alternatives, the procedures, the workflow, results, conclusions, and references. The background of this innovation is actually coming from our operational issues. As we all know that the geothermal production well in the liquid dominated well is having two phases of the liquid. But the liquid will be separated between the brine and the steam in the separator. We all know that the steam will be delivered into the power plant to produce the electricity, while the brine will be reinjected back into the reinjection well. After the separator, we will find the outlet of the brine, and then will be accumulated the geothermal brine into the pond. And then during the reinjection process, due to the cooling period of the brine in the geothermal pond or maybe another channel pathway, we will find the brine deposits in our area. So these brine deposits will have the impacts or the issues in our operational activity. The first issues will be the found of the silting pond. The second one is the stop of the venting, the clogging of the strainer. So what when we do with this brine deposit, except we will throw it away as a waste. So there is three alternatives of the solution that we can conduct and modify of the brine deposit into the commercial one. The first product is the brick. The second one is a paving block. The third one is the oil absorbent. Based on our considerations of the operational issues, maybe the oil spill in our field, maybe from the durations, from the commercial rate, from the difficulty level, and the raw material availability, we have chosen the best one is the oil absorbent product as the modification from our brine deposits. So the workflow of our innovations coming from the preparation and collections, and then we have done the manufacturing, maybe this is the observation, the trial, the experiment, then the packaging and the drying, the trial and error, and the implementation of this product. The procedures of these innovations is, the first one is the preparations. In the preparation process, we will collect all the deposits in the geothermal pond, in the geothermal brine channel, or maybe another location in our field. And then we will do the draining process using the oven, and then we have done the experiment in the laboratory. In this experiment, actually, we will have the failed one and the succeed one of the product of our oil absorbent. So the succeed one, we will have the implementation of the succeed product into the several spots of our oil spill potential in our field. The first spot is the low oil tank, and the second one is in the fuel oil tank spill in our vehicle pool in our area. So based on the results in trial and error observation in our laboratory, we have found the best formulations, the best trial, and the best results in our innovations. These two formulations is the absorption and conversion percentage based on the weight and volume of the raw material and the final product of material. So this is the result. The second one is the calculations of the absorption capacity, where we have comparisons between the weight and the volume of the absorbed oil. So based on these three treatments, we have found that the percentage of our absorption capacity in our product is more than 95%. So during the observations, trial and error, we have found that there is a specific chemical content that can make the loose material from the brine deposit into the solid one. The first chemical content is nitrogen hydroxide. The second one is cornice adhesive. The third one is the cement. So based on these three chemical content, cornice adhesive is the best one that have the best absorption percentage capacity, which have more than 95.6%. So what is the best compositions? Either the weight or the volume, or maybe the draining time of the cornice adhesive that will have the mixture with the brine deposit. So we have also conducted 3 treatments based on the difference weight of the cornice adhesive and the draining time. And then we found that the best treatment is we will have the ratio between the weight of the brine deposits and then the weight of the cornice adhesive is 10 to 1 gram, with the draining time is 2 hours. We will have the absorption percentage capacity is also more than 95.6%. So this is the treatment, how the raw material, which is brine deposit, will have the conversions percentage into the final product. So based on this 3 treatment with the 3 different weight of the material, we will have more than 97% can be converted into the final product from the raw material as the brine deposit. So the last one is the table of the comparison between our product with another common product of absorbent in the market. So based on these 5 comparisons of the product, we will found that our product, which have the absorption percentage capacity, is 95%, while another absorbent in the common or maybe in the market absorbent that we found easily is above 95% also. So this conclude that our product is quite similar in the effectivity and then the usefulness in our product compared to another commercial product. So we also conduct an analysis of what is the composition detail in our brine deposit. This is the list of our chemical content in our brine deposit, and the maximum one composition is a chloride and the second one is silica. This is how the picture of our final product in our oil absorbent in Lumut Balai field. So the conclusion of my presentation today that geothermal brine deposit of Lumut Balai field can be reused to be the oil absorbents using cornice adhesive solvent with high absorption capacity is about 95.6 or 0.8%. So the producing oil absorbent can replace the future purchase of absorbent in the market, such as 3M, and then sand, and then sodas, and etc. And the third one is the utilizations of geothermal brine deposit have given the value added from our visions to beyond geothermal energy. The oil absorbent will not exactly harm the environment and operational since the deposit will be taken regularly to save the pond and drain injection system. So the point of this innovation is what can we have a value added from our issues become our revenue. That's what we want to reach from these innovations. Since this is the references that we use, we have done and we have created our own operational procedure to create the oil absorbent from our geothermal brine deposit. And then we have the comprehensive well report and point report from Thermochem Indonesia. And also we also conduct the analysis from our laboratory. So that's all my presentation today. Thank you very much for your attention. I'm happy to hear your questions and I'm looking forward for your question in my email. Thank you so much and goodbye.
Hello everyone. In here, I will present our paper with title of Study of Potential Cascade Direct Use to Utilize Exhaust Steam from Break Pressure Turbine at Ulumbu Geothermal Power Plant. Here our background, the first one is Forest Island as Geothermal Acid Island, but it only has 2 geothermal power plant that has been utilized. The first one is Mataloko and Ulumbu Power Plant that will be discussed in this paper. And exhaust from Ulumbu Geothermal Power Plant back pressure unit still have a large thermal energy. And here our objective, we will generate analysis of the potential of cascade direct use to utilize exhaust steam from the back pressure turbine at Ulumbu Geothermal power plant. Here our methodology, we have literature study and remote survey area to analyze the product. And then we analyze the heat transfer and thermodynamic and analyze a little bit of environmental impact analysis. And we will have proposed cascade direct use utilization scenario. And here the thermodynamic aspect, because this paper is pre-feasibility study, we assume that there is no heat loss and no pressure loss at piping at heat exchanger. So the equation will be simple enough. The purpose of direct use of geothermal is air conditioning in this paper. So the psychometric chart can represent several important properties of the moist air. And here the literature study, the current condition at Ulumbu Geothermal working field is located at Satarmesi district with reserve of 100 megawatt and utilization of 10 megawatt. It has 2 back pressure unit and 2 condensing unit. For the back pressure unit, it has high thermal energy for about 2,400 kilojoule per kilogram. And here the geographic and climate based on NASA. We use this for the moist air analysis. And here demographic and socioeconomic. There is 20% household in poverty condition. And for the largest condition has for about 10,000 household. And the most of household in the largest condition is located at Satarmesi sub-district. And here the plantation commodities, we have cashew and coffee. And for the animal farm, we have kampung chicken in 13,000 kampung chickens at Satarmesi district. And for the vegetable, we have tomato, and the fruit, we have banana. And here the feasibility of direct use geothermal. The first one, we choose coffee. Why? Because it's famous, but the farmer is still in poverty based on Tagar ID with the derivative of Anthony. Then because the long market change, the price drop. There is UPH or farmer group that has the highest price, but the UPH is minority because most of farmer has a rent, so they must sell the coffee to the rent collector. And here, the coffee production per year in Satarmesi district, and the second selected local community is X. Why? Because at the animal farm communities, it has the highest production with average egg production is for about 1,300 eggs per day based on Manjur 1989. And here, the egg zone that most potential hatching state is for about 35 until 40 degrees Celsius. And the last one is tourism. Why? Because there is no hotel and no geothermal tourism in here. And this idea came up from onsen in Japan. And the tourism can improve community economies. And for the scenario that we have 2 scenarios here, no working fleet, the geothermal well as the working fleet, or with secondary working fleet, water or anything. But due to the economic value, we choose the first scenario. We use geothermal well fluid as working fluid. And for the location, we choose the location near the Ulumbu power plant because there is no coffee industry near the Ulumbu. And here the coffee drying, step 1. We must change the cherry into the green bean with the geothermal coffee dryer. Based on BPS Kabupaten Manggarai, Satarmesi district has the production of 300 ton per year with 5-month production. And here the specification, we choose 1 ton capacity with 40 kilowatt. And based on the productivity, we choose 5 geothermal coffee drying. And this the egg hatching. We have three heat exchanger with some case is incubate stage 1 and stage 2. And here for the stage 2, we have egg hatching in here. We have 3 heat exchanger with some heat exchanger is for stage 1 incubation, and the last heat exchanger is for the stage 2 incubation. And this for the geothermal swimming pool, we modified from 0 to 20 and 17. Heat loss due evaporation is take place where there is a difference in partial pressure, water vapor at pool surface and in the air over the pool. And the second heat loss is the convection. It associated with heat loss caused by air pressing over the pond surface. And based on the calculation, the evaporation heat loss has the most significant value. The swimming pool will fed by filtered geothermal water continuously. And after filtration, geothermal water temperature is decreased into 28 degrees Celsius. And because the geothermal water flow rate is limited and not enough to meet the freshwater requirement of the pool for the turnover period, some part of pool water is filtered and recirculated to the pool. Because of the heat loss of the pool, the temperature of pool water decrease, and it has vital importance to design the pool to keep the pool temperature at the range of the standard. And here the socio-economic feasibility based on Van der Waals 20 and 20. First, we create community profile and project profile and construct theories of change. The first one is geographic location. It's located at Manggarai Regency, is Nusa Tenggara, Indonesia. And the main natural resource based on literal study is plantation and agricultural products, but there is also hint about development of material and mining and earthenware commodities. And the main livelihood is the plantation is agricultural too. And for the community structure, Manggarai Regency is divided into 12 districts and 132 sub-districts. And services availability, there's a total for about 2,000 kilometers of road that connected through state, provincial, district, and village road in Manggarai Regency. And half of them are in good condition. For vulnerability factor, there is a scarcity of information regarding the community's vulnerability towards internal and external threat. And here the project profile. The first one is ambition of the project. There's a potential to expand the capacity in the maximum of 20 megawatt energy in the future for the Ulumbu power plant unit 5 and unit 6. And for the collaborating organization, it's mainly controlled by direct of PTPLN with direct supervision from the Ministry of Energy and Mineral Resources of Indonesia. And for the main project activity is geothermal activities, installed renewable energy tech is geothermal power plant with condensing unit and back pressure unit. And for the decision-making structure, it will supervised by PLN gas and geothermal. And then for the community engagement, power plant has direct energy utilization for the local, but there is no information if first the local community is engaged with power plant activities. And for the revenue, currently the business model of this power plant is provide electricity for the public and business sector from the generated power of 10 megawatt. And for vulnerability, until right now, there is no social issue in Ulumbu geothermal power plant area. And the last one is the theories of change. The first one is local economic development. The Ulumbu power plant could position itself as the reference for the local economic development based on geothermal direct use. And for the knowledge and skill enhancement, the establishment of this direct use should have needed multiple functional and skill from manpower accurate. Thus, the requirement of the manpower is going to one of the requirement to be fulfilled. And the next one is impact. Based on the planned operation date, there is no claim with wide range of reliability that has been experienced by locals that live around the area of Manggarai Regency. Last but not least is around the tourism opportunity. This opportunity is part of power plant facility could be great initiative as well as for the stakeholder, both local at Manggarai Regency as well as PLTP Ulumbu business activity. Even though geothermal energy is considered as clean energy, there's still several environmental impact caused by the process products. Among the many types of pollution, we will focus at hydrogen sulfide. Here the table for the effect of H2S gas concentration on human health in different concentration. And this paper will review the summary of several technologies that are available in the market. There is a cooling tower with ethane, 82, sulfur, right? And there is LOCAT and AGS, and there is a sulfate. For the condensate, the cooling tower with ethane is the cheapest, but for the NCG, the sulfuride is the best for the small amount, but LOCAT is the best for the efficiency, and sulfate is the best for the carbon capture and sequestration. And for the both condensate H2S and NCG, the H2 technology is an option, and H2S it can produce the syngas. And during the concussion, the steam accrued from back pressure turbine can be used as working fluid on the Cascade system. And the direct utilization can be developed into coffee dyeing sector, egg hatching, and tourism. And from the economic aspect, the direct use of geothermal can boost the economic growth along the local communities. And the technology choice that available for H2S removal are the cooling tower with ethane, At2 technology, sulfuride, LOCAT, and Ag2S. And thank you.
Hello everyone. In here, I will present our paper with title of Potential Alternative for Geothermal Direct Use in Mataloko to Increase Public Acceptance. For the background, Indonesia have big geothermal potential is about 23.9 gigawatts, and the Flores Island, as the geothermal island, is the one of great geothermal potential in Indonesia. But there's a social acceptance issue in Flores, especially in Mataloko geothermal area that will be discussed in this paper. For the objective, we will populate the option for geothermal direct use in Mataloko based on the available geothermal resource, potential usage, or communities, and socio-economic condition in the area. And we will analyze the option to evaluate the potential advantages or disadvantages for the local communities. And here our workflow. We do literature study or desktop study, and we use the data information from set survey from PT Rixis Energy Indonesia, and we analyze the potential option and also analyze the advantages or disadvantages and generate summary metric of the analysis result, and also identify path forward for the study. And here the current geothermal development status in Mataloko. We have probable reserve of 62.5 megawatt with proven only 2.5 megawatt. There is 6 wells in total with MT4 well temperature is about 104 degrees Celsius with around 10 bird gates of wellhead pressure. And here in the diagram is indicated the use of geothermal energy based on its temperature. Then we move on into information of communities. We have population data of Ngada Regency based on BPS or Statistic Agency of Kabupaten Ngada. Gorewa Sub-District has the most population in Ngada Regency, and the Mataloko power plant is located at Gorewa Sub-District. And for the gender, the female has the most portion in Ngada Regency. And here the socio-economic and infrastructure data, even though the other sector has the most economical value in Ngada Regency, but in the specialized sector, the agricultural, forestry, and fisheries has the most portion. And the road, the infrastructure, the most road in the Ngada Regency is district roads. In here we have coconut and Arabica coffee as the most commodities in Ngada Regency. And here for the other, there is red bean, there is also ginger and turmeric. People in Mataloko reject the project because of their horses were damaged, and there is a strong sulfur smell, and it affects their agricultural crops. There's also corrosion on resident roof because they use sand as their roof. And here for the site survey information, the Mataloko Geothermal Power Plant has capacity of 2.5 megawatt with single cylinder type condensing geothermal steam turbine. But right now it's severely damaged and unable to be repaired. And here for the manifestation, we have Waluja with hot stream with temperature of 91 with acid. And also Togesa crater is type smart pool with temperature of about also 94, but it's unknown its acid or base. And here the geothermal well information. The MT1 is not flowing, the MT2 is not flowing, and the MT3 is flowing. In here, it's shown that the MT1 does have the wellhead, but for the MT2, the wellhead is good, but there is no geothermal activity at there. For the MT3, also it's good, but there is no geothermal activity on the well. And here for MT4, MT5, and MT6, the MT6 is injection well, so we will reject it. And for the MT4, it have enough data for water temperature and the pressure. The wellhead is also good. And the pressure gauge is claimed to be accurate and representative. There is a leak in the cellar, so it will need a rework on the substructure. And here for the hot spring pool and space heating, we have Mangeruda, Malanagi, and Boba. For Mangeruda, there is infrastructure, there is pool, Azaria, and bedroom, but for the Malanagi and Boba, there is no infrastructure at there. And for the space heating, there is no use of space heating for the residents, but it may be used as chicken or other farming. And here the site survey information about the coffee, there is 23 UPS or unit pengolahan hasil or coffee farmer communities with 286 members with production of about 548,000 kilogram per year. And for the dyeing process, it has very important role, but it has large cost generated for dyeing process. And there's also Forest Bajawa Arabica Coffee MPIG is the one of coffee industry near the Mataloko power plant. It's managed for about 128 UPS, consists of 10,000 farmers. And based on Forest Bajawa Arabica Coffee MPIG, it's required the capacity of coffee dyeing about 500 kilogram. And here for other industries such as the palm sugar industry, there's no palm sugar factory in the region. And for the brick factory, there's no. Also for the bamboo, there's a bamboo factory, but it's on construction. And for the roof tile, there's no tile plant, but the PLN CSR is the tile molding machine, but it's not been distributed yet. And here, the manifestation assessment. The value of the hot spring is not feasible due to there is no access in infrastructure and the steam is random. And for the Togosa, it has emits H2S and it's very active, so it's not feasible. And here, the well manifestation assessment. The empty one is not feasible, even though it has steam exist at there. Because the road is still dirt and narrow. And for the MT2, there is no steam, so it's not feasible. And for the MT3, it's not feasible due to the road is dirt and narrow. And for the MT4, it's most feasible because it near the big road and the steam is exist, even though the H2S is found on the wellhead, but it's small enough. And for the MT5, it's not feasible right now because the roads is still dirt and narrow, and for the MT6, it's just injection well. For the direct use option assessment, we have commodity drying, geothermal pool tourism, and animal husbandry or space heating. For the commodity drying, we need for about 100 degrees Celsius. And there's two options here. We use the local industry. There is Arabica Coffee MPIG, but it located 8 kilometers from Mataloko power plant. The advantage is it will expand the industry, but it will have the high cost due to piping installation and material. If the installation is bad, the temperature will be high. And for the option 2, we build the new industry in near Mataloko power plant. The advantages is less temperature and pressure drop, but it will have high cost due to civil work. For the community dyeing, it's very much needed to speed up the dyeing process for the local communities. And for the geothermal pool tourism, it's only need 40 degrees Celsius. And there is two options also, expand the hot pool manifestation or build artificial pool. The expand hot pool manifestation, it less cost, but there is no access to the manifestation. And for artificial pool, it's more feasible, but yeah, it will have high cost due to massive facility construction. There's no need geothermal tourism right now, but it can be utilized to increase tourism community. And for the animal husbandry, we choose chicken egg incubation. It's need for about 60 degrees Celsius, and for the advantage, it will increase chicken fertility rate. And we think that there is no disadvantage for this option, but it's currently not needed, but it can be an option for the future use. And here the proposed geothermal industrial area. This is the PLN building. We propose to build near Mataloko power plant and near the well. And for the local community assessment, we have clove, ginger, coffee, and candlenut. For the clove, it only need 3 until 5 days. In the ginger, it's needed, but it only provide added value. And for the coffee, we think it's very needed because the coffee need about 20 days if the weather is good enough. For the candlenut, it's only 3 until 5 days. And for the coffee, the number of harvest per hectare is still high enough. It's about 2,000 kilogram with high commodity price too. And for the benefit, the most impactful one is geothermal tourism. It will increase economy over the time, but it will have high investment to do that. But based on the urgency of rejection from the local communities, we propose to dyeing the local communities with the most feasible one is coffee dyeing. And for the other option is Cascade direct use, and for the other option is Cascade direct use. It may be reasonable consecutive arrangement to utilize energy at different thermal level and get a few items such as commodity dyeing, animal husbandry, and geothermal tourism. So the conclusion is the most suitable potential for geothermal dry application is dyeing with MT4 well, and the commodity is coffee. And with the fast forward, we must assess the suitable utilization geothermal dikes in Mataloko and make a detailed study for the options that have been generated. And thank you.
Good day, everyone. My name is Erwandi. As a speaker who will present the research that did by my college and I, it's about identification of the potential of geothermal energy used for vaccine COVID-19 cold storage box using absorptive refrigeration. The outline in this presentations are introduction, area recommendation, energy balance equations, result, discussion, and conclusion. As we know, the COVID-19 outbreak has become a global pandemic, and on April 14, 2021, the time when we began our research, there were 138,147,801 confirmed cases of COVID-19 globally. Meanwhile, in Indonesia, the cases recorded on April 14, 2021 were 1,583,182 cases. The large number of confirmed cases, especially in Indonesia, makes it necessary to take steps to deal with this COVID-19 case. One of them is with a vaccine that can increase the body's immunity. However, there are obstacles in the vaccinations, one of which is in its distribution of vaccines. Vaccines require low temperature storage, which is around 2 until 8 degrees Celsius. Meanwhile, Indonesia has obstacle in low temperature storage facilities. Therefore, as a solution, we conducted research to design a cooling system for vaccine storage using direct geothermal utilization. Why geothermal? Because Indonesia has potential geothermal energy reaching 28.5 gigawatt. And so the purpose of our research is to discover the possibility of using geothermal energy in Tompaso, North Sulawesi, especially in Tompaso Community Health Center for cold storage of 5 liters or around 1,000 vials of COVID-19 vaccine using absorptive refrigeration, and also to identify the temperature for storage of COVID-19 vaccine. The location we chose was in Tompaso, North Sulawesi, with geothermal power plant is Lahendong, Unit 5 and 6. We chose Lahendong Geothermal Field, Unit 5 and 6, because it is the closest source from the hospital or health center, and is also close to the residential area. The cascading system only uses brine from PLTP Lahendong Unit 5, and based on the map, the distance from the geothermal field to the health center by following the injection pipe is 1.29 km, and to the hospital is 6.5 km. The location of the source is very important to be chosen, which is close to the health center or hospital, so that the heat can be used efficiently. And the following are the characteristics of the brine parameter of the Lahendong PLTP Unit 5. Can we see that from the data of the brine? The PLTP Lahendong Unit 5 have the most favorable thermodynamic characteristics, such as highest temperature, pressure, and flows. And in this research, we use energy balance equation, and there are 4 equations. The first one is mass flow rates balance equations. M dot in equal to M dot out equal to mass flow rate total. And for the second equation is to know the power equal to M dot multiplied by delta enthalpy. And for the third equation is the heat U multiplied by A multiplied by delta TLN. And for the delta TLN, we can find with the equation 4. And for the coefficient of heat transfer, or U, we can see from the table. And there are various type of the heat exchanger that we use. We use 2 type of heat exchanger, shell and tube and plate. For absorber, desorber, condenser, and evaporator, we use shell and tube. And for SHX, we use plate heat exchanger. So based on our calculation than we did. The design for the vaccine cooling system is shown in this picture. The working fluid, ammonia water, is heated in a heater with a heat source from brine in flow 13, so that the sum of the working fluid becomes steam in flow 9. The composition of the vapor is almost entirely ammonia, very little water content, because ammonia is more volatile than water, so that the vapor composition is almost entirely ammonia. This is why ammonia will act as a refrigerant to cool the vaccines, while water acts as an absorbent. The vapor, due to the low density, will go to the top of the separator in flow 1 and will be reduced in pressure through the expansion valve, so that in addition to decreasing the pressure, the isoenthalpy temperature will also automatically decrease, so that the temperature is cooler in flow 3. The cold refrigerant is used to cool vaccine. In the evaporator, the cold refrigerant in flow 3 will absorb the heat from the vaccine. So the refrigerant will evaporate in flow 4. The refrigerant from evaporator in flow 4 will mix with the absorbent in flow 12. The liquid content at the bottom of the separator contains a small amount of ammonia, because most of the ammonia goes to the top of the separator, so that the bottom liquid is called a weak solution in flow 10. Flow 5 to 9 are called strong solution because they contain a lot of ammonia, compared to the flow 10 to 12, which have a little ammonia or weak solution. The high temperature weak solution in flow 10 is dissipated in solution heat exchanger, so that the heat is absorbed by the strong solution in flow 7. Before entering the heater, the liquid whose heat has been removed or has cooled in flow 11 is reduced in pressure PRV until the pressure is equal to flow 12. The mixture in flow 5 becomes a strong solution due to the mixing of flow 12 in weak solution with refrigerant, which is almost entirely ammonia, so that the mixture contains more ammonia in a strong solution. This mixture in flow 5 still contains steam, so that as a condition for entering the pump, this mixture must be entirely liquid. So it must be cooled first with a cooler, so that the entire mixture is liquid in flow 6. After the mixture is completely liquid, the strong solution absorbs the heat from the heat exchanger solution, so that the temperature rises in flow 8. Then it is heated and evaporated in a heater with a Brine geothermal heater. And here is the result of our design. We can see that in the evaporator, the inlet temperature is 1 degree Celsius in 0.3, and after cooling the vaccine, it becomes 5 degrees Celsius in 0.4. There are two working fluids that we use. The first one is brine with a mass flow rate of 109.61 kilogram per hour and the temperature of 170 degrees Celsius as a heat source, and a mixture of ammonia water with an ammonia content of 30% and a mass flow rate of 36.25 kilogram per hour. In these mixtures, ammonia is a refrigerant and water is the absorbent. So the cooling load for Sinovac vaccine, Sinovac vaccine is the vaccine that we use in the research, is 1.03 kilowatt with 1.05 meter cubic of volume cold box storage. The average temperature of the coolant or evaporator is 3 degrees Celsius. This temperature is suitable for Sinovac vaccine cold storage requirements, which is 2 until 8 degrees Celsius. And this is based on Kim research on 2020. In addition to the Sinovac vaccine, this cold storage can also be used for other types of vaccines, such as AstraZeneca and Janssen vaccine. This is because these two types of vaccines have the same storage temperature as Sinovac, but have different cooling rates due to the difference in vaccine material, because difference in heat capacity. However, this storage cannot be used in vaccine Pfizer, BioNTech, Moderna, Sputnik V, because they have a storage temperature well below the cold storage we designed. We designed 3 degrees Celsius, and the temperature is negative. And the application of refrigeration systems, the heat source must be able to heat ammonia water until 70 degrees Celsius, and for hospital locations close to the heat sources, so less chance of heat loss. So from our research, we can conclude that the vaccine cold storage in the Tompaso area has the potential to use an energy source from the Brine Lahendong geothermal power plant for cooling the vaccine. and the absorption refrigeration system simulation, the average evaporator temperature is equal to 3 degrees Celsius, and this is suitable for the cooling the vaccine that have a cold storage temperature to until 8 degrees Celsius. And the working fluid used in the absorption refrigeration system is ammonia water with the cooling load 1.03 kilowatt, and the cooling load brine is equal to 109.61 kilogram per hour from the Lahendong geothermal power plant. And the absorption refrigeration system for vaccine cold storage has a cooling performance or COP equal to 0.43. And that's all in our presentations. Thank you so much, and good day, everyone.
Hello everyone, my name is Zagy Berian, and today we'll present our paper with a title Preliminary Study on Geothermal Direct Utilization, a case study of greenhouse optimization at Wayang Windu geothermal area. This is the outline of the presentation. We begin with the introduction that describes background of the paper consists of previous research on the same topic. Then we move to the literature study to support the paper, and then the methodology that explains a step that conducted in the paper. Then we move to the result and discussion, end up with the conclusion and recommendation for further research. Here we go. Based on the worldwide installed capacity of geothermal power plant, Indonesia is the second largest installed capacity in the world that installed around 2,000 megawatt. Indonesian government has a target regarding energy mix, with the current condition is still far away from the target. Geothermal energy is one of the long-term solutions to achieve renewable energy target in the energy mix, because the geothermal can provide a stable electricity supply for 24 hours per day, 7 days a week, and 365 days per year. Besides that, it's clean energy and abundant but untapped. The government set the target at the end of the 2035. The installed capacity of geothermal power plant have to reach 9.3 gigawatt. Do you know there are two-way utilization of geothermal power plant? The first one is a common utilization that everybody knows is generating electricity. In Indonesia, more than 10 geothermal working areas with different technologies such as dry steam, single flash, and organic rankine cycle. The current installed capacity in Indonesia has reached around 2,000 megawatt. Another way to use geothermal energy is direct use. Directly extract heat from the geothermal fluid. There are so many applications from the direct use, such as geothermal heat pumps, space heating, greenhouse, covered grounding, aquaculture, agriculture, and industrial. But only few utilization in Indonesia and still pilot project phase. Let's move to identify the potential area. West Java is one of the area in Indonesia that has prospect for direct use utilization. The previous research explained the steps to select the area for the direct use. They identified the potential area that indicates 43 prospect area which distribute in 11 regencies. Then from the 11 regencies, it will be eliminated again based on the requirement to several areas such as Kamojang, Kawadarajat, Awi Bengkok, Patuha, and Wayang Windu. The previous research used the matrix of assessment consists of the presence of the existing industry, type of reservoir, and preserved forest that show the Wayang Windu is the most suitable for direct use implementation. Then there is another previous research that conducted preliminary study of direct use for the drying plant. The current condition from the industry is using diesel oil for heating process. Regarding the rough calculation, the geothermal energy can provide energy 10 times higher from the current energy needed. For the economic sector, the geothermal energy is favorable when the fluid considered as a waste. Is the greenhouse is only designed for a tea? No. There are another common vegetable for the greenhouse heating, such as cucumber, lettuce, and the tomato. The figure shows the effect of the temperature on the growth of the vegetables. The yield production will reach the highest value if the temperature is on the optimum temperature. In the global, the installed capacity of the greenhouse is around 2,500 megawatt. Fun fact, in Indonesia has not used the direct use for the greenhouse yet. It's very interesting to conduct the preliminary research for the greenhouse from the geothermal direct use. But is there any fruits or vegetable that has high economic return to cultivate in the greenhouse? Based on the information in the public, capsicum annum or paprika has high potential to cultivate because it has high price and high demand in the market. The question is it possible to cultivate capsicum annum in the greenhouse? Absolutely yes. There are several farmer and a commodity in Indonesia that cultivate capsicum annum but use the traditional greenhouse that only utilize heat from the sun through a transparent wall. So this paper will examine the capsicum annum using greenhouse system from Wayang Windu's Brine. The greenhouse will design into several bays, use the common design, and accommodate a stable condition along the year. The heat transfer occurs in the parallel heat exchangers using geothermal hot water to heat up the fluid for the greenhouse. Moreover, this paper will show the greenhouse design and the environmental aspect of the direct use utilization. Let's move to the character of the area and plan. The resource estimation from Wayang Windu is around 6 megawatt if the temperature of the hot water can decrease from 180 to 150 degrees Celsius with 50 kilogram per second mass flow rate. The area of Wayang Windu is still available for build a greenhouse. For the capsicum annum has optimum temperature between 21 to 33 degrees Celsius. The price of the capsicum annum is between 2 till 5 US dollar per kilogram. With the greenhouse, the yield production will increase 10 times compared with the open area. There are several greenhouses that has been built for cultivate the capsicum annum in Indonesia, especially in Bandung. For the component and heat loss calculation, there is a method from the Nelson that adapt ACME standard to the design greenhouse heating system. The method needs a standard heat loss value for the component and need factors correction to estimate the total requirement heat for the greenhouse. For the environmental aspect, the life cycle assessment is a common method to obtain the carbon dioxide emission. It only needs geothermal and diesel emission factor and multiple by the same annual production from both types. We move to the methodology. The first step is select the optimum temperature regarding the condition of the surrounding and the characteristic of the capsicum annum. This paper selects 33 degrees Celsius for the optimum temperature. Then, the paper designed the greenhouse with 10,000 meters square or 1 hectare that divided into 6 bays. The closed loop system used pipe to transfer the heat to the surrounding of the greenhouse. For the heat transfer fluid, the water selected as heat transfer fluid in the heat exchangers. The heat will rise to the surrounding of the greenhouse. After that, find the standard heat loss for each component, then multiply by each factor to obtain the corrected heat loss. Last, the total of corrected heat loss will be a minimum heat required for the geothermal to supply. This design will extract heat from the Wayang Windu at only 10 degree decreasing temperature from 180 to 170 with counterflow shell and tube heat exchangers. The counterflow is suitable to get lower area for this case when comparing with the parallel flow. Moreover, the emission factor for the diesel and geothermal are 0.33 ton carbon dioxide equivalent per megawatt hour and 0.047 ton carbon dioxide equivalent megawatt hour. This is the design of the greenhouse. There are 6 bays with total 1 hectare area. The pipe configuration is on the top of the roof and parallel for the 6 bays of the greenhouse. The heat exchangers will transform the water from the liquid phase into steam using the geothermal heat. The dimension of the greenhouse is 18.3 meter times 91.5 meter times 3.65 meter, consists of the globe, wall plastic, roof plastic, and curtain wall. For the heat loss calculation, a total requirement heat that has to fulfill by the geothermal fluid is 200 kilowatt. For the total greenhouse, it needs 1.3 megawatt. This value is only 20% from the total estimation resource. To determine the pipeline, the total required heat divided by heat supply capacity from the pipe material types. The result, this design requires 1,000 meter for one bay or 6,500 for all the greenhouse. For the environmental aspect, the carbon dioxide emission for diesel and direct use are 100 ton carbon dioxide equivalent per megawatt hour and 88 ton carbon dioxide emission per megawatt hour for 1,800 megawatt annual production. In other words, direct use utilization will reduce 86% of carbon dioxide emission. To implement the greenhouse, this study select a location that near from the re-injection well. The figure beside show the location target of the greenhouse. This location is near from the vacation area that is suitable for increasing attention of the people and also educating them regarding the greenhouse. The conclusion, the greenhouse was designed for 1 hectare, was divided into 6 bays using Cascade cycle from Wayang Windu power plant. The capsicum annum selected as a plant to cultivate the greenhouse based on the opportunity in the market and feasibility produced in Bandung, Indonesia. The minimum heat supply for the greenhouse is 1.3 megawatt from the wastewater. The greenhouse will reduce 86% of the carbon dioxide emission when comparing with the industrial diesel oil. For the recommendation, the further research on this study may include more detailed calculation on the heat exchangers and economic evaluation on the proposed design such as IRR, NPV, and the payback period. That's all from me. Thank you.